So this section is about ellipses, and if you remember, an ellipse is just one of the conic sections. So it's just the shape that you get when you cut a plane through the cone. All right. So we're going to look at all of these from the geometric perspective here. So well, you can see here that an ellipse is the set of all points in the plane, the sum of whose distances from two fixed points f1 and f2 is a constant, and these two fixed points are the foci, plural focus. So if you remember how an ellipse had a focus, then well, a parabola had a focus, but an ellipse has uh, two of them, so they're foci. Now, in a way, I hope that you can sort of see that this is just really, in a way, like one parabola representing half of the ellipse and another parabola representing the other half of the ellipse, in a way. So it makes sense that the term focus or foci applies here as well. So one thing that you do need to sort of remember here then is that the center is actually right here. All right, so the center of the ellipse is actually right here, and then the f1 notation is just for the focus number one, and the f2 notation is just for the focus number two. And these foci will always actually be inside of the ellipse. Now, when they say that the sum of the distances from the two fixed points is a constant, I mean that this distance right here, that pink distance, is equal to this distance, the green distance right here. All right, so you could pick any point on the ellipse and then draw the segments from that point on the ellipse over to the foci, and then the length from focus one to the point on the ellipse over to focus two would all be the same length. All right, so here we're dealing specifically with ellipses with the center at the origin. So we have the equation of the ellipse here, x squared over a squared, and then that's plus y squared over b squared equals 1. So the key here is to remember that these are all pluses here. All right, so we'll deal with the hyperbolas next week, and the hyperbolas have minuses. Now, the other thing that you need to remember is that here it says a is greater than b greater than 0. So that means that we need to just look at which one is going to be the larger value, right? So think about this: if the a is greater than b, which is greater than 0 here. Let me just double check that. I want to say it this way. Okay, then that means that the a is a bigger value, right? So this is going to be the larger value because a is greater than b. But then just try to remember then that if a is greater than b greater than 0, then remember here this is going to be the larger value. All right, so the a is whatever the larger value is here. So think about like this: the if the a, the larger number, is under the x squared instead of under the y squared, then the a's are on the along the x axis, and if the a is under the y squared instead, then the a's are on the y-axis. All right, so that's how you determine which one is the a and which one is the b, and how you graph this. And then you can see the vertices are plus or minus a0. So this is a vertex, and this is a vertex, and then you have the major axis. So this actually is the right here is the major axis. All right, so the major axis is always whatever the longer axis is. So wherever you see the larger number in the denominator, that one will be the major axis automatically. And then the other one right here is the minor axis. All right, so that one's the minor axis. And then the other thing that you see is that the c squared is a squared minus b squared. So really, then, well, I think that if you look at what is going on here, you could probably figure out how you got that geometrically by drawing a triangle, but I really am not sure. Like I was saying, like I'm not sure that you need to go through all of that. Just remember that you can show that if you want to. So similarly over here the vertices are at the A. So this is a vertex, and this is a vertex, and then this one is now the major axis, and then the other one is the minor axis. All right, so if you have any questions about this, please just ask. But right now, I just want to make sure that you knew what all of the items were that were listed here in the box. So here is the eccentricity definition of the ellipse. So the eccentricity is just E equals C over A, and then you look here and remember that before, remember how you got the C for the foci? It was C squared equals A squared minus B squared. So if you look at this, if you square this, C squared is still A squared minus B squared. So the eccentricity is just using the value C from the foci over the value A, the value from the major axis. And then the eccentricity of the ellipse is any number between 0 and 1. All right, so here we go. So let's find the foci and the vertices and the lengths of the major and minor axes. So the length of major axis and the length of the minor axis, so major axis, minor axis, and then we want the eccentricity, and we want to sketch the graph. All right, so we'll do all of these things here. So remember the foci were at, now, by the way, we sort of want to make sure that we know which one is the larger value. So the 64 is the larger value. So the a squared will be the 64 and the b squared will be the 36. All right, because the a is greater than b greater than 0. So the a is the larger one. So if a squared is 64, then that means a is the square root of 64, which is 8. And if b squared is 36, that means b is the square root of 36, which is 6. So the foci, remember, we're at the plus or minus C0. The vertices are at plus or minus a0. The length of the major axis was 2a, the length of the minor axis 2b, and the eccentricity was c over a. So all we need to do is figure out all of these and then sketch the graph, all right? So, well, I know a and b, but I don't know c, but I know that c was the square root of a squared minus b squared. So that's the square root of 64 minus 36. So then the 64 minus 36, well, that is 28. And so the square root of 28 is about 5.3. All right, so I know the foci are at plus or minus 5.30. And then the vertices are at plus or minus a0, and a was 8, so plus or minus 80. And then the length of the major axis was 2a, so that will be 2 times 8, 16. The length of the minor axis is 2b, so 2 times 6, 12. And then the eccentricity is c over a, so that's the square root of 28 over 8, and the square root of 28 over 8 is about 0.66. All right, so that's everything that I needed. So now I just sketch the graph, and then I know that because the larger value was under the x squared, that this is the x-axis is the major axis, and I know the other one is the minor axis, and then I go, let's see, I go 8 each direction from the origin on the major axis. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And there we go. So there's my 8 and 8. And that's how I get a length of 16. 8 plus 8, 16. And then I see that the B was 6, so I go that many up and down on the minor axis. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then that's how I get that the length of the minor axis was 12. 6 plus 6, 12. And then I just go ahead and I draw the ellipse as best as I can here. All right, so this isn't going to be perfect, but it's as good as I can get today at least. And that's it. So hopefully you enjoyed that. That shouldn't be too bad, I don't think. You just have to make sure, especially to pay attention to which number is the larger number, the number under the x squared or the number under the y squared, because that will tell you which is A and which one is B. All right, so this is a vertex, and that is the vertex. So always remember the vertices are always on the major axis. All right, so now let's try another one here. So again, if you have any questions, let me know. But I am going to write the format up here again. So here we go. So remember that the equation is either going to be x squared over a squared plus y squared over b squared is equal to 1, or it's going to be x squared over b squared plus y squared over a squared is equal to 1. But then it's always whichever one is the larger number is the a. But if you notice, the equation here says that this is equal to 1, but here we have something equal to 81. So what I'm actually going to do is just divide by the 81 to get this equal to 1. So 9 over 81 is 1 over 9. So I have x squared over 9 plus y squared over 81. And then 81 over 81 is 1. So then I see that the larger value is under the y squared right here. So I'm going to use this format right here. All right, so now let's write down everything that we need it to find here. We needed the foci, we needed the vertices, we needed uh, the major axis, we needed the minor axis, and we needed the eccentricity, and also a sketch of the graph. All right, so the foci are at 0 plus or minus c, vertices at 0 plus or minus a, length of major axis 2a, length of minor axis 2b, and eccentricity is E is c over a. So we're in the same situation as before, that we know what a is, because a squared is 81 and b squared is 9. So a is the square root of 81, 9, and b is the square root of 9, 3. So the c squared was square root of, what is that? That would be a squared minus b squared. So the square root of 81 minus 9. So that's the square root of 72, which is about 8.5. So the foci are at 0 plus or minus 8.5. Vertices are at 0 plus or minus a. So 0 plus or minus 9, and then the major axis is 2a, so 2 times 9, 18, minor 2b, so 2 times 3, that will be 6, and eccentricity, square root of 72 over, oh boy, 9, so that will be about, uh, well, let's see, I think it's like 0.94, so let me just double check. I can't even find my calculator, so yeah, it's okay. Well, actually, you know what? Here it is. Yeah, so square root of 72 over 9. Yeah, that's about 0.94. All right, so now we just need to draw a sketch here, and then I know that the major axis is on the y-axis because the larger number was under the y squared, so that means I need to go up 9 each direction from the origin on the y-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then let's see here. We have to go 3 each direction on the x-axis or along the minor axis. So that will be 1, 2, 3 each direction from the origin. So now here you go, and you can go ahead and graph this today. All right, so the one thing that I do want you to notice though is what happened to the uh to the shape as the eccentricity got closer to 1. All right, so you see how this one had eccentricity about 0.66, and this one had eccentricity 0.94. The closer it is to 1, the more elongated the oval will be. All right, the closer to 0 that the eccentricity is, the closer that the ellipse will look like a circle. Because if the eccentricity is equal to 0, then it is a circle. All right, so keep that in mind as well. So you kind of can get a guess of, like, if you even have a shape that looks close by, if the eccentricity is closer to 1 or closer to 0. All right, so let's try another one. So again, if you have any questions, please feel free to ask, but find an equation for each ellipse and sketch its graph. All right, so we know that the center is at 0, 0, and the foci are at plus or minus 4 zeros, at plus or minus c0, and the vertices are at plus or minus 5 zeros, at plus or minus a0. So since we know that 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, negative 5, 5, then the vertices are always on the major axis. So that means that since this is a vertex and that's a vertex, This is the major axis. So that means we need to use x squared over a squared plus y squared over b squared is equal to 1. And so we know that the a was 5, so 5 squared. So we just need to figure out what the b is, but we know what c is. So we know that c squared is the a squared minus b squared. So c was 4 and a was 5. So we have 4 squared is 5 squared minus b squared. So 16 is equal to 25 minus b squared. Then subtract the 25 from each side. So negative 9 is equal to negative b squared. Divide by negative 1. So 9 is b squared. And so you know b squared is 9. But if you take the square root on each side, you get b is equal to 3. So you go 1, 2, 3 up, 1, 2, 3 down, and 3, negative 3. You draw the ellipse, and you are done, because here's 3 squared, so you have x squared over 25 plus y squared over 9 is equal to 1. What a time to be alive, right? So I hope that all makes sense of how I went about finding the equation for that ellipse. I tried to just look at what information they gave me and then went from there. All right, so the next one, we see that we have the foci at 0 plus or minus 4. So we have 0 plus or minus 4. So 1, 2, 3, 4. 1, 2, 3, 4. So this is, say, F1, F2. And then the length of the major axis is 14. So that means that if 2a is equal to 14, then a is equal to 7. So that means I need to go up 3 more. So 5, 6, 7. So there's 7. And 5, 6, 7. Here's negative 7. So now I know that they've told me C and they've told me A. But because the foci are always on, again, the major axis, I know that the a has to go under the y squared here. So x squared over b squared plus y squared over a squared is 1. And I know that a is 7. So I still need to figure out what the b is, but I know that c squared is a squared minus b squared, but c is 4. A was 7, so 4 squared is 7 squared minus b squared. I know this is I know this isn't exciting, but we have some easier ones coming up, hopefully. So 16 is equal to 49 minus b squared. Then we can subtract the 49 on each side. So that will give us a negative 33 equals negative b squared. I'll divide by the negative, so that would be 33 is equal to b squared, and I take the square root, so b is equal to the square root of 33. So we have square root of 33 squared, and then, well, the square root of 33 is about 5.75, so that means I have to go about 5.75 on the x-axis each direction from the origin. And then I go ahead and I draw the ellipse. All right, so there you go. There is the ellipse. Whoops. And so this is the negative square root of 33, and here is square root of 33. So then if I go ahead and I square out the a and the b here, I have x squared over 33 plus y squared over 49 is equal to 1. All right, there we go. What a time to be alive. All right, so now let's try another one here. So we have the eccentricity is 0.75, and the foci are plus or minus 1.50. So here we go. So the foci are always on the major axis. So we have plus or minus 1.50. So we know that this is plus or minus C0, and we know that E is C over A. So since E is C over A, then since E is actually 0.75, and then C was 1.5, and we have over A, then we can solve for what A is. So let's just cross multiply here. So 0.75A is 1.5, and then you just go ahead and you divide by the 0.75. So that will give me A is 2. So here is 2, negative 2, here's 2. And so these are the vertices. So there's a vertex, and so now I know that the form of the equation must be x squared over a squared plus y squared over b squared is 1, and that I have x squared over 2 squared, and I still need to find out what b is. But just like before, I know c squared is a squared minus b squared. So c was 1.5, so 1.5 squared. A was 2, so 2 squared minus b squared. And 1.5 squared is 2.25, and 2 squared is 4. So we have 2.25 equals 4 minus b squared. Subtract the 4 from each side. So negative 1.75 is equal to negative b squared. Then divide by negative 1. So 1.75 is b squared. But then b is the square root of 1.75, which is about 1.33. So this, if you look at it, since this is 1.33 and 1.33, this is actually a very small ellipse, but this is the square root of 1.75 and negative the square root of 1.75. All right, so there you go. So, excuse me. So then if I put in the square root of 1.75 squared here, I get x squared over 4 plus y squared over 1.75 equals 1. And here is a case where I think that most people would not want to have the fractions and the decimals mixed together. So then that's when you would say, well, 1.75 is actually, well, that is going to be, well, here, 1.75 is 1 3/4, or that's going to be 7/4. So then I have here, what do we have? We have x squared over 4 plus y squared over, and really, because this is y squared over 7 over 4, it's actually multiplying by the reciprocal. So it is going to be, right, if you multiply by the reciprocal of 7 over 4, it's actually 4 over 7. So 4y squared over 7. So 4y squared over 7. And then what you would do is you will multiply by the LCD of 28. So 4 times 7 is 28. So 28 over 4 is 7. So 7x squared. And then you would have the 28 times 4 over 7 would be 16. So 16y squared. And then 28 times 1 is 28. So you can write it like this if you would like to get rid of the fractions. Otherwise, you can leave it like this. All right, either is okay. But again, if you don't want to deal with the fractions and the decimals together, then you would have to clear the denominator like this. And then this is why sometimes you don't see the ellipses being written as equal to 1, and you have to divide by the 28, or like in the one example, we had to divide by 81 to figure out that it was an ellipse, because they may have cleared the denominator like this. All right. So again, if you have any questions, please ask. But I feel like here a lot of these are just following the formulas step by step, and it ends up being okay. So let's try another one here. So we have the eccentricity is the square root of 3 over 2. So E is the square root of 3 over 2. And the focus is on the y-axis, and the length of the major axis is 4. So then that means 2a is 4, and a is 2. All right, so we know that the eccentricity is c over a. So if a is 2, then we have the square root of 3 over 2 equals c over 2. And so then we can see that c is equal to the square root of 3, a is equal to 2. And then just like before, c squared was a squared minus b squared. So the square root of 3 squared is equal to 2 squared minus b squared. Square root of 3 squared is 3. 2 squared is 4 minus b squared. Subtract the 4 from each side, so negative 1 is negative b squared. I'm telling you that these will be actually the hardest ones that we have, I think at least. So hopefully you'll feel like they get easier after this. Then divide by negative 1, so 1 is b squared. Then I'll take the square root on each side, so b is 1. So since the focus is on the y-axis, then you know that the equation is going to be x squared over b squared plus y squared over a squared is 1. But then b was 1, and a was 2. So we have x squared over 1 squared plus y squared over 2 squared is 1, or x squared over 1 plus y squared over 4 is equal to 1. So there you go. That's the equation. But then I will go ahead and sketch this, and you can see that if the major axis is the y-axis, and I have an a is 2, 1, 2, 1, 2, so negative 2, 2, and a b is 1, so 1 each direction on the x-axis, then I can easily just sketch the graph of this ellipse. All right, so again, the vertex is always on the major axis, so that's a vertex and that's a vertex. All right, so I hope that you're enjoying this. So let's go ahead and try to find the equation of the next ellipse here. So here we have a point at 0, 5 and a point at 2, 0. So we see that the distance from the origin is actually larger on the y-axis at 5 versus 2 on the x-axis. So that means that the a has to be the 5 and the b has to be the 2. So the equation for the ellipse with the y major axis is, again, x squared over b squared plus y squared over a squared is 1, or x squared over 2 squared plus y squared over 5 squared is 1. And so we have x squared over 4 plus y squared over 25 is equal to 1. So there you go. What a time to be alive. So we just have a couple more pages here. So if you have any questions, please feel free to ask. But I feel like this is fairly straightforward here. So here we have the focus is 0, 3, and we have the vertex at a 0, 4. I know that's a vertex because the focus is always on the major axis where the vertices are at. So I know that A is 4, B or C is 3, and B is not given. But I do know C squared is A squared minus B squared. So this is 3 squared is equal to 4 squared minus B squared. But 3 squared is 9, 4 squared is 16. So then I can subtract 16 on each side to get, we have 9 minus the 16 is, what is that going to be? That is going to be -7, so -7 is negative b squared. Then I will divide by -1 to get 7 is equal to b squared. And then I'll take the square root on each side to get b is equal to the square root of 7, or about 2.65. So this is right here, negative square root of 7 and square root of 7. So now if I want to go ahead and write the equation of the ellipse, because the major axis is on the y-axis, I have x squared over a squared, b, b squared plus y squared over a squared is equal to 1. So x squared over the square root of 7 squared plus y squared over 4 squared is equal to 1. Or the square root of 7 squared is 7. So I have x squared over 7 plus y squared over 4 squared is 16 equals 1. So what a time to be alive. There you go. That is the equation of that ellipse right here. So now let's go ahead and do the next one. Again, if you have any questions, please feel free to ask. Since this one is going to blend a little bit together, I'll try to use a different color marker here just to keep these separated. So this one, I am given a 2, and I'm given a -1 and a 2. So all I know here is that this is an x and a y, and then because here is actually, look at this right here. This is actually 0, 2. So I know that whatever this number is right here has to be bigger than 2. So that means that this is the major axis. And that means that this is the minor axis. So that means what I'm given here is that b is equal to 2, and this is the a value that I need to find here. All right, because this is -1, 2, then that means that this has to be 0, 2, and that a has to be bigger than 2. So that means I have the equation x squared over b squared plus y squared over a squared is 1. And then I have to actually use this equation then to figure out what a is. So I do know that x is -1, so -1 squared. B is 2, 2 squared. Y was 2, 2 squared. A I did not know, so a squared is equal to 1. So this is a little bit different because a wasn't given and c wasn't given either. But I was given a point at -1, 2 I'm going to use here. All right, so now -1 squared is 1, 2 squared is 4, so 2 squared is 4, and then a squared is a squared. So subtract the 1/4. So 4 over a squared is 3/4, and then I will go ahead and I will cross multiply here. So I have 3a squared is 16. Then I'll divide by 3. So a squared is 16 over 3, or a is the square root of 16 over 3, which is about 2.31. So it is a little bit bigger than the 2. All right, so then I just write down the equation of this ellipse. So it's x squared over b squared, so 2 squared, plus y squared over a squared, so the square root of 16 over 3 squared equals 1. So x squared is over 4 plus y squared over 16 over 3 equals 1. And again, some people might not like the double fraction or the complex fraction there, so they might go ahead and multiply by the reciprocal to get x squared over 4 plus then that would be 3y squared over 16 equals 1. And then you can clear the fraction by multiplying through by a 16, 16, 16. So I'm left with 16 over 4 is 4, so 4x squared plus 3y squared is equal to 16. So that's another way to write the equation of the ellipse if you don't want to write it this way right here. All right, so those are some examples of writing the equation of an ellipse. So again, I'll pause this for a moment here. So I actually did not mean to do that, but all right. So again, if you have any questions, feel free to ask, but I was going to move on to the that would be page 319. So here is an example here. So a bridge over a waterway has an arch in the form of half an ellipse. All right, so I might actually go ahead and get a little bit, a little bit creative here. Here's the waterway, and here is the bridge. All right, so I hope that you are sort of familiar with this sort of the sort of bridge here, right? So what you're talking about is those sort of bridges that look like this. All right, and then there's an ellipse right here, and then the equation of this ellipse, and by the way, half of the ellipse is under the water. All right, so I mean you can draw the birds here, and you can draw the sun here if you want, but you're not going to see the other half of the ellipse because it's under the water. All right, so that's why it said half an ellipse. So the equation of that ellipse is 400 x squared plus 256 y squared is 102,400. So this is not actually in the regular form for an ellipse. So I'm going to go ahead and divide this by 102,400 so that it's equal to 1 here. So then 400 over 102,400 is 1 over 256. So this is x squared over 256. And then 256 over 102,400 is just 1 over 400. So it's y squared over 400. So actually, that conveniently worked out for us. Now we know that the a squared is always the larger one. So that means b squared is 256 and a squared is 400. So the square root of 256 is 16 and the square root of 400 is 20. So all I know then is that if this is the center of the ellipse at say 0, 0, then it's 16 in each direction. All right, so 16, so that would be negative 16, and 16, that would be 16, and then it's 20 each direction up and down. So this would be 0, 20. All right, so this is just like the same thing that we've done before. And again, if you're really wondering like where the bridge is, right? This is the bridge, and people are driving over the top of the bridge and coming down. So I'm not trying to scam you. This is this is actually what's going on here in terms of the the bridge, and I can draw the cars even if you want me to draw cars. But the next part of the problem said a sailboat whose mast is 18 feet above the water is approaching the arch. So will the mast clear the bridge? So will the mast clear the bridge? And then they want to know why or why not. And then also how wide is the base of the arch? All right, so I can tell you that the boat will indeed clear the bridge because the arch is actually 20 feet. Is it feet? Yeah, feet tall at the center. So as long as the sailboat is going down the center or close to the center of the arch, then it should clear the the arch. So here's the sailboat. All right, here's the sailboat, and the sailboat is 18 feet tall. That's not a shark, it's a sailboat, and so it is shorter than the height of the arch. So yes, the mast will clear the bridge because the the arch is 20 feet tall. And then it wants to know how wide is the base of the arch? Well, the base of the arch is going to be, well, that's 32 feet. All right, so 16 plus 16, 32. So 32 feet. So I hope that you enjoyed this example here. I don't think it was too difficult. It looked a little bit more intimidating than it really was, I think, because of the 102,400 there. So here's another example. The highway passes beneath an overpass that is in the shape of half of an ellipse. So this is sort of actually almost the exact opposite of the one that we just had. So the highway is actually passes beneath the overpass this time. So almost the same diagram, but the road that we want is the road going into the road that we want is the road going into the distance. So this is like when you go on those tunnels and on 696 and then you fear for your life because icicles are falling from the roof of the tunnels and you think that your windshield is going to be knocked out by an icicle. That's what this is like here. So then the overpass is 15 feet high at the center. So here we go. So we have 15 feet high at the center. So here is 15 feet high, and then it's 40 feet wide at the base. So here is the 40 feet wide. So that means that this whole thing is 40. So that means half of it is 20. So we have negative 20, and we have a 20, and we have a 0, 15, especially if these are supposedly at the origin, right? So then what is the equation of the ellipse? And then it wants to know also a truck that is 10 feet wide and carrying a load that is 14 feet high is approaching the bridge. And if the truck goes down the middle of the road, will it clear the bridge? And why or why not? So first, let's figure out the equation of the ellipse. So we know that the B is going to be the 15 and the A is going to be the 20 because the 20 has to be the A because it's larger than the 15. So the equation is x squared over a squared plus y squared over b squared is equal to 1. So a was 20, so x squared over 20 squared plus b was 15, so y squared over 15 squared is equal to 1. So we have x squared over 20 squared at 400, and y squared over 15 squared is 225, and that's equal to 1. So then the thing that you need to know then is this time it actually did not tell you whether or not how tall the truck was. It just told you how wide the truck was, right? So, well, actually, yes, it did. It actually did. I didn't see it. It said on the next line at 14 feet high. So we know that if it's going down the center, all right. So if it's going down the center, that the truck is going to be 10 feet wide. So that means 5 and 5, and it's going to be a 14-foot tall. So here's my truck. So here are the wheels. I know my truck isn't very good. So here it is. All right. So there's my truck. So it's 14 feet tall. So now what I see is that the corners of the truck are the real issue here. All right, so the corner of the truck is the real issue. So I need to know at this point, 5 comma y, whatever that is, and this will be 514, will the y value of the arch be bigger than 14? Because otherwise, the corner of the truck is going to take out the arch. So hopefully that all makes sense of what is going on here. So what I actually need to do then is I need to substitute the 5 in for x and figure out what y is. So 5 squared over 400 plus y squared over 225 is equal to 1. So 5 squared is 25. So 25 over 400 plus y squared over 225 is equal to 1. It really doesn't matter, in my opinion, if you use decimals here or not. It's because as long as you don't round to the end. So 25 over 400 is 0.0625 plus y squared over 225 is equal to 1. So subtract the 0.0625 from 1. So we have y squared over 225 is 0.9375. Ooh, and then I hope that this truck is delivering like breakfast or something, because I'm actually starting to get pretty hungry here. And then I will multiply by 225 here. So then we will take the square root after that. So, oh no, okay, so I actually thought that I had this up on my calculator. So y squared is going to be 210.9375, and then I will take the square root on each side. So y is approximately 14.52 feet. So I do know that this is 5 and then 14.52. So that means that the arch is actually going to be taller than 14 feet, the height of the truck at that point where the corner of the truck would be. All right, so that's it. That's all you really need to know about this. So yes, the the truck the truck's load will clear the bridge if it goes down the center. All right, so I hope that you enjoyed this example here about the truck here and the deliveries. So I'm going to